Welcome to Financial Analytics. In today's video, we are going to discuss what is a heat map, how to create a heat map in R, how to apply financial data to heat map, and how to interpret the heat map with these financial numbers. So to create a heat map, we are taking a Tata Motors financial ratios. So what is a heat map? Heat map replaces the numbers by colors. So the colors represent the numbers. And how to interpret the heat map? Lighter the shade of a color represent the number is lower. The darker is the color of a shade, or particularly dark red color indicate the number is high in that cell. So if our data is in a rows and the data is related net profit margin, if the cell has a very dark red color, that indicate that the profit is very high or net profit margin is very high. If the color of a shade of a net profit margin cell is in a pink or is a very light in a light color, that indicates that the net profit margin is low. So in this way we can interpret the heat map with the help of colors. Light colors means low number, dark color means high number. So we basically, human beings are very convenient or find it very easy to interpret with the colors. So heat map provides a solution to interpret the numbers, and this is very helpful for a common man. So let's create a heat map in R. So let's move ahead. So before moving to R Studio, let us take one example of heat map application in financial data. So this is Yahoo Finance website, and Yahoo Finance uses heat map to represent the changes in share prices as compared to its previous day, and they show that change in a heat map format. And you can see here, this is a heat map of US listed companies, and the key characteristics or key aspects of this heat map is there are squares, and the squares are of different sizes. And on what basis Yahoo Finance differentiate the company's square sizes, that we have to keep in mind. And the second point is the color combination. The color combination that Yahoo Finance uses, there are two colors, green and red. So let us understand why these square sizes are different. So to understand this, we have to read this. The size is defined as a market cap of a share price. So this Apple has a larger square size in the universe of this stock price data, and Apple has a pink color. So pink color represent the stock price is declining as compared to its previous day's share price, but the square size is the largest because the Apple has a market cap of 2.4 trillion. Similarly, if you go somewhere here, SEC Limited, which has a market cap in billion. So Apple has a market cap in trillion, and other companies have a market cap in a billion. So that reflect the difference in these square sizes. So larger the market cap, larger is the square size. So this is the way we can interpret. And these colors are red and green. Red represent the stock price is declining as compared to the previous day's share price. Green color indicate the stock price is increasing as compared to the previous day price. More the darker red color, more is a decline of a share price. More is a greener, more is an increase in price as compared to its previous day's share price. So you can interpret. So Amazon is increasing, or a share price of Amazon is increasing today as compared to its previous day's share price. Now Apple is in pink. Apple is not in a red. Red means the share price is declining substantially. So Apple price has a pink color, which represent there is a some decline, but that decline is moderate. So the decline is minus 0.09%. So that's why the color is not red, color is a pink. But obviously there is a decline. So in this way, we can interpret the heat map. So let's move ahead to our studio to create the heat map. To create a heat map, I have imported our Tata Motors file and stored it into a Tata M variable. And now if I want to check how my data looks like in R, so when I imported this data, R is treating it as a table data frame, and the data has a 9 rows and 6 columns. 9 rows means there are 9 financial variables and there are 6 columns. So 6 columns means first column is a financial ratios and next 5 columns are related to financial years, which stores numeric data. Now, if I want to check the structure of this data M, the structure is look like this. The first column is a financial ratio, which stores a character data. And then rest data are financial years, March 21, March 2019, March 18, and March 17. All these data are stored into a numerical format. So all this data has a numerical format. Now, if I want to see how our data is clean, is there any missing data? So I will first write is.na. Now what this is.na function will do, is.na will find out how much data is missing in this file. And there is a mistake. And so what is.na function is returning me? So false, 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 and false. What does exactly it means? If there is any missing data, it will treat as a true. And if there is a no missing data, then it will treat as a false. And for every false, R assign a 0 number. And for every true number, R will assign a 1 number. Now there is a no true and everything is a false. So when I write this code, give me a sum of is.na of data M, R will return me 0. So why this 0 appears? Because there is a no single true. If there is any true, R will return me a number 1. And this is a sum. For all false values have a 0 number. So when R find out the sum of all these false, it will get a 0 because every false value has a 0 number. So sum of a 0 will result into a 0. So sum of a false is a sum of a 0. So that's why there is a result is a 0. So there is a no missing data. Now let's move ahead. Now, what is the crux of this creating a heat map? What heat maps wants? Heat map needs a data in a matrix format. If the data is not in a matrix format, we cannot create a heat map. Now, let's try to find out what kind of a mistakes we will make. So give me a heat map of Tata M and I will definitely get an error, because what R want this Tata M into a matrix format. And see this head of Tata M to understand the problem. This Tata M has two types of data. The first data is operating profit margin, which is a character data, and rest data from March 21, March 20, 19, 18, and 17 is in a numeric format. So we need in a matrix a data which is of a numeric data type. So let's move ahead and try to rectify this error. So give me a Tata R, and if I create as dot matrix of Tata M, see what happens. And if I write here Tata R. Now, what is a Tata R? Tata R is a matrix that we have just created. Now, when we create this Tata R matrix, we will get this matrix. Now, this matrix is not a numeric. See, this is the first column is operating profit margin, which is a character. So that's why R has converted this matrix entirely into a numeric format. So you will find only characters inside this matrix. So what we have to rectify, how to rectify this mistake, that we have to remove this column, and then entire data will be treated as a number in R. So let's create a new matrix, Tata ratios, and then remove this column, Tata M, and remove the first column. So write down simply -1. -1 means give me data frame by excluding the first column. So you can see now how our Tata ratios is look like. So Tata ratios. So Tata ratio is look like this. Now it is a table. So we will convert Tata ratios into a matrix, because without converting a data into matrix, we cannot create a heat map. So Tata ratios, then adds dot matrix, and then Tata ratios. In this way, we have converted our Tata ratio into a matrix format. So if I check the class of Tata ratios, I will see here matrix and array. So in this way, we have removed the first column, because the first column is a character, the financial ratios, and that's why if we do not remove that column, R is treating the entire data in a character type. So our data is in a numeric format, but due to the first column, which has a character financial ratios for labels, so we have to remove that column. So let's move ahead now, how our Tata ratios is look like. So Tata and ratios. So in this way, our Tata ratio matrix is looks like. Now what we will do, we will give row names to these rows 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because the column heads are available, the financial years, only what we need, the row names. So how we can give the row names to our data? So write down row names to Tata ratios, from where we will get the row names. So Tata Motors, and give me a financial ratios column. And now if you check Tata ratios, it looks like this. So what is this? This is a matrix format of a Tata ratios, because what we want to create our data into a matrix format. So now we are ready to create a heat map. So let's move ahead. So to create a heat map, right, heat map, and of what heat map you want? I want a heat map of a Tata ratios. So our heat map is ready, and now if we make it bigger, we can see it, how our heat map looks like. Now what R is doing, see here, this net profit margin, gross profit margin, operating profit margin are correlated to each other. And if you see on a left axis in this area, this is called a dendrogram. And what this dendrogram does, the dendrogram summarizes the information of a group of a value and sort them according to the values. So net profit margin, gross profit margin, operating profit margin are highly correlated to each other. So it creates a cluster of these groups. So you can see here the net profit margin and gross profit margin are in this dendrogram are co-created in a one group. So that this is a one group. Now in this one group of a net profit margin and gross profit margin, there is a one another group added, that is a operating profit margin, and to this group this current ratio group is added, and in this way you can interpret it. So similarly you can interpret current ratio and quick ratio have a single line which is attaching in this dendrogram. So the row wise dendrogram interpretation is important, because in this column, these columns are the financial year, they are by default related to each other due to their financial data. So let's move ahead. And so we have created a dendrogram with a heat map. And if I want a heat map without this dendrogram, how I remove this dendrogram? So I will simply write heat map and heat map of Tata ratios, and then row WV, and I don't want row wise dendrogram, so I'm writing here NA. So you can see the entire row wise dendrogram has gone. And if I also want a heat map without a column dendrogram, I will simply write here column call V is equal to NA. And now my heat map is very much clear. Now how to interpret this heat map? Now earlier when we created a dendrogram, this net profit, gross profit margin are created into a one cluster. So now they are separated. Now we have a heat map without a dendrogram. So the basically dendrogram we basically heat map we interpret with the colors. And you can see the fixed asset turnover ratio is very high in March 17 and March 18, and then the fixed asset turnover ratio is a declining. So this is the way, the first row that we can interpret of this histogram. Similarly, if we check this profitability ratios, net profit margin is very high in March 17, and then it is a declining. So this is the way the dendo in heat map we can interpret the net profit margin. Similarly, about a gross profit margin is very good in March 17 and March 18, but after March 18 it is declining, and that is the impact of COVID-19. Similarly, similar to gross profit margin, this operating profit margin is also declining after March 18 and March 19, March 20 and March 21. We can find out that or interpret that the operating profit margin is declining. So this is a explanation about a heat map and the way we can create a heat map with a dendrogram, without a dendrogram, and how we can create a dendrogram with a column or with the rows that we have discussed. So let's move ahead to the next videos. Thank you.